flat bottom a little U between the 1 foot and the 3 foot long, and which ends about the 6 inches long. So the figure clearly indicated. Here you just see that the crack is there, and the non-variable length as well as the location and the orientation of the staple, so that the tension across the crack is distributed in the concrete rather than the concentrated in single plane. So it is not necessary that the half of the portion on the one side of the crack and the half of the other side. You can make the changeable length may possible, and this stapling which has been done by carrying out the hole by the outside. So this hole will be filled by lastly by the epoxy. So this procedure, which is referred as the stitching process. Let us see one small video based on the stitching process. I wish the voice will be there. Voice will be there. Please check it out. The voice. It has been some complaint that there is no voice, so would like to once again screen sharing done by myself. So now check it out the audio. The voice is not there. Why? Please check once again. Why voice is not there? What is the window? Oh, and touch screen. So there is super instances. So we call it I think some of the message has been received that there is no voice from the video. We are trying our best to sort out these issues. I will show the stitching procedure. Now the repairing of the crack by the external stressing by means of the prestressing steel. So here the application of the prestressing steel for the repairing condition which has to be used. So when there is a major portion of a member is to be strengthened, post-tensioning is often desirable solution. So here in this technique, the cracks can be closed by introducing a compressive force because cracks will be generated because of the tensile force. So the opposite to that, the compressive force, which has to be generated by applying the pre-stressing steel, which is sufficient to overcome the tension and to provide a residual compression. So here the principle is very similar for the stitching, except that the stitches are tensioned rather than the plain bar dolls, which is apply no closing force to the crack. Here in this technique uses the pre-stressing strands or bars to apply compressive force. So some form of the abutment is also needed for providing an anchorage for the pre-stressing wires or rod, as shown in this image. Here in this particular first figure you can visualize that if we crack this there and we have to apply this tension tie over here, that will create the compressive force to close the crack. See the another image for the same approach before self-fundamental. The actual image which has been shown over here. Now, external pre-stressing. Here, can we visualize that the pre-stressing tendons are placed on the outside of the physical cross-section of the force which are to be exerted by pre-stressing tendons are only transferred to the structure at the anchorages and at the deflectors. External cross-tensioning can be used to improve the performance of any kind of the beam bridge like timber, reinforced concrete, distress concrete, steel, or composite. Another repair technique that is we discussed about the grouting. Grouting is a process of injecting the mixtures of cement, sand, water at the high pressure in the cracks, joints, voids, etc. This has been done, which is the same manner as of the injection of an epoxy. But here the grouting can be carried out with any kind of the material. Not only the epoxy, you can use the cement paste also. So first of all, they clean the concrete along the crack, then install built-up cess at interval along the crack, seal the crack between the seats with a cement point or grout, and lastly, flush the crack to clean it, paste the seal, and grout the hole, and finally inspect the crack at the last stage for a long time period. Now, the basic purpose of grouting is to strengthen the porous concrete, to prevent the seepage in dam and the water in the structure, to reduce the uplift pressure below the dam, and to fill the cracks in concrete structure. One of the image before grouting and after the image after the grouting. Now, this detailed procedure of the grouting followed by the following ways. The first is the drilling of grouting holes. That is, to apply the grouting, we have to carry out certain holes with certain strategy. For drilling grouting holes, equipments like the jackhammer, diamond drill, short drill, etc. to be used, and the choice of the type of the drilling equipment depends upon the type of stone, size of hole, depth of hole, etc. Then arrange the grout pipes. Grout pipes of the 4 to 5 cm dia, 40 to 90 cm length are inserted into the grout holes, and the space surrounding the pipe is filled with the help of the cement mortar. The top end of the pipe is connected to the pump. Finally, the cleaning of the cracks which is to be required before injecting the grout mixture so that the proper bond which can be carried out. Then we have to insert the grout into the holes with certain pressure, specifically 0.65 kg per cm square per meter depth hole. There are certain types of grouting. The one is the consolidation grouting, second is the stage grouting, third is the curtain grouting. This consolidation grouting, which is used for the shallow depth grouting holes, normally at a pressure below 3 kg per centimeter square, which is also known as low pressure grouting. While stage grouting, here it is to be required when the thick layers are to be grouted. The total thickness of the layer is divided into the stages of 1 meter each, and the grouting of each layer is to be carried out one by one. Here, the grouting of the upper layer, which is started only after the grout in the lower layer had properly set. The third one is the curtain grouting. This type of grouting is done to prevent the seepage of water below the foundation of dam. Grouting holes are drilled in the upstream side of the dam in the bedrock. An impermeable grout wall is to be created to prevent the seepage of water through the dam foundation. Now, based on the grouting material, there are also three methods: the Portland cement grouting, chemical grouting, and the epoxy grouting, depending upon the material to be used. If we are using the Portland cement grouting, certain procedure that we have to follow. The first one is the widen the cracks, particularly in the gravity dams as well as thick walls, which may be repaired by filling the Portland cement ground. This method is effective in preventing the water leakage, but will not structurally bond cracking sections. Here, the procedure is the same as the cleaning. First of all, the concrete along the crack by air jetting, by water jetting, then installing ground at the suitable intervals, and after that, we have to sealing the cracks between the seals with the sealant and flushing the cracks to clean it. So after doing the application of the grout, the test of the shoe to be done, and then grouting the whole can be carried out. The grout mixtures is nothing but the cement plus water or cement plus sand plus water, and this depends on the depth of the crack. Water reducers or the admixtures can be used to improve the property of the grout. For the large volumes, a pump may be used, and for the small volumes, a manual injection gun may be used. See the image of the figure which is clearly shown the grouting procedure. Chemical grouting, which can be used for grouting using the sodium silicates, maybe urethanes as the elements. Two or more chemicals are also combined to form a gel as opposed to the cement grouts consisting of the suspension of the solid particles in the fluid. The advantage of the chemical grout that can be applicable in the moist environment. Also, this chemical grouting can be applied in very fine cracks. See the image here, the chemical grout which is to be used over here. The next procedure, that is nothing but the blanketing. The term itself understands blanketing, which is used for the load of repair. It is similar to the grouting and sealing, which is used in the larger scale and applicable for sealing active as well as inactive cracks. Here, the first step is to carry out the grouting. That is, making the chase is the first step. Usually, this chase or the grouting is to be done in a cut square shape instead of the V-groove that we did in case of grouting and sealing, here which has been done by the cut square. The bottom should be chipped as needed to facilitate the breaking the bond between the sealant and concrete. But if you see the figure here, it should be a square or maybe the beloved chase which has been done over here instead of V-groove. The sides of the chase should be prepared to provide a good bond with the sealant material. The first consideration in the selection of the sealant material is to amount of the movement anticipated and the extremes of the temperature at which such movement will occur. So there are four types of the blanketing joints. The type 1 which can be used for the elastic sealant, type 2 for the mastic sealants, type 3 is a mortar plug joints, and this is research is filled by the mortar, while the water-tipped bar used as a type 4. See the images. The sealed chase which can be shown over here. So nothing but a rectangular portion which can be filled by the sealant. The next technique for the repair is nothing but overlays. Overlays may be used to restore a spalling or a disintegrated surface or to protect the existing concrete from the attack of aggressive agents. Overlays used for this purpose to include the concrete or mortar, bituminous compound, etc. Overlays is nothing but the spreading of something on the bigger area. Here, the epoxy should be used to bond the overlays to the existing concrete surface. Overlay is used to seal cracks. Overlays are also used when a large number of cracks are there. Fitting each crack is expensive. For active cracks, overlays done with the material which are extensible but not flexible, like polymeric membrane with the top coat of tar. For the inactive cracks, any type of the overlays may be used, like polymer modified Brooklyn cement mortar or concrete or by silica film concrete. Accordingly, an overlay which is flexible but not extensible can bend but cannot be stretched, will not save a crack that is active. Here, the gravel is typically used for the roofs, for the overlays, and the concrete or brick are used when the fill is to be placed in the overlay. An asphalt block pavement also works well where the area is subject to the heavy traffic for the overlay is concerned. Another method to use repair is nothing but the drilling and plugging through cracks. This technique is only applicable when cracks run in semi straight lines and are accessible at one end. This method is mostly used for repairing of the vertical cracks in retaining wall. One of the appropriate methods that to drill the holes normal to the crack, fill them with the suitable epoxy or epoxy mortar formulation, and then place reinforcement bars of the predetermined size and length, and then stitch across the cracks. Here the bars will be placed in the two holes prior to filling the epoxy, but then great care is to be needed not to penetrate any air so that the effectively repair can be carried out. Here, a hole typically of 50 to 75 mm in diameter should be drilled, centered on hand following the crack. If you visualize the figure, centrally a hole which is allowed in this figure image that of 50 to 60 mm minimum diameter into the stem. Now, this hole must be large enough to intersect the crack along the full length and provide enough repair material to structurally take the load exerted onto the key. The drilled hole should then be cleaned, made tight, and filled with the grout. The grout prevents transverse movement of the sections of the concrete adjacent to the crack. Here, the key will also reduce the heavy leakage through the crack and loss of the soil from behind the leaking wall. Water tightness is one of the important criteria over here, and the structural load transfer is not. The drilled hole should be filled with the resilient material with the low modulus of elasticity. Here, the key effect is essential, and the resilient material can be placed in a second hole to fulfill the ground, as shown in the figure. Now, for any kind of the repair, after doing that, the long-term monitoring strategy is very much important to see the effectiveness of the repair. This long-term monitoring strategy may be in terms of the visual inspection, maybe the kind of the debonding, because visual inspection is to be needed because finally at certain stage the debonding can be observed after certain time. We have to also monitor this visual inspection that Effectiveness of the handling of the chloride content may be the moisture content. It is also utmost necessary in this long-term monitoring about the measurement of the carbonation depth, and the reinforcement corrosion assessment should be required in the long-term monitoring. Now, after doing the repairing condition, let me proceed further the retrofitting. What is retrofitting? What are the retrofitting techniques are there? And how it will be useful to us for which kind of conditions that we have to understand. Now, as per IS 13935, retrofitting is nothing but to upgrade the earthquake resistance up to the level of the present day by appropriate techniques. Newman in 2001 gave a definition that retrofitting is an upgrading certain building systems such as mechanical, electrical, or structural to improve performance, function, or appearance. Means that retrofitting is nothing but the structural strengthening of a building whether or not an earthquake has occurred. What is the need for retrofitting? The first one is existing weak, unsafe building which is required for the retrofitting. Building not designed to as per the codes which is needed for the retrofitting to enhance the load carrying capacity, to catch up the load carrying capacity against the earthquake. Upgrading of code based on the seismic design courses. Upgrading the seismic zone, as the seismic goes to just in one place, which is before it is in zone 3, now it is in zone 4. Based on the surging seismic activity, it needed the retrofitting. Relation of strength on aging of the structure also needed the retrofitting. Modification of the existing structure affecting its strength adversely need retrofitting. Changes in the use of the building, increasing the floor loads, which also needed the retrofitting. Higher cost of the rebuilding than that of the strengthening or retrofitting, which needed the retrofitting. There are certain various reasons are there for the retrofitting, maybe the more than this which is listed over here. Now, here the one image shows that clearly. Here the first graph shows the P versus delta curve, loads versus deflection curve, or you may say the moment versus theta curve, rotation curve. Here it will be clearly visualized that the existing structure and its displacement and the retrofitted structure and its displacement versus load carrying capacity. So you can see that there will be a drastic increase in strength will be there after retrofitting technique. There will be increase in the ductility also involved because of the application of retrofitting, and increase in the stiffness can be observed because of the retrofitting technique. But another figure shows the energy dissipation capacity of the retrofitted structure versus the existing structure. So graph is nothing but the energy versus time. The full line shows the retrofitted structure and dotted line shows the existing structure. So energy dissipation capacity is also enhanced for the retrofitted structure in comparison with the existing structure. This image clearly shows the permanent deformation control of retrofitted structure versus existing structure. In the dotted line, which is clearly shows that there is certain permanent deformation will remain in the structure, in the existing structure, but when we apply the retrofitted structure, that permanent deformation is very, very negligible. So these are the advantages of application of the proper retrofitting technique to be applied. Now there are certain steps of the retrofitting to be needed. The first one is the evaluation. Evaluation is the major and important step for any structure to be there, and in which the first step is the structure analysis. The analysis of any structure, existing structure, should be carried out by the linear static or dynamic, maybe non-linear static or non-linear dynamic. Any method which has to be applied depending on the type of the structure, category of the structure, and need of the structure, the method to be involved. And after carrying out this one, is we find out what are the deficiencies involved in the retrofitting, and then the decision of the retrofitting has to be carried out. The selection and the design of the retrofitting strategy which has been adopted after that by doing the design, fitting the design strategy. Then verification of the retrofitting strategy which has to be done, and once again do the structural analysis by using the applied retrofitted structure. Then we have to go for the construction side, that is application of the retrofitting strategy, and finally is the monitoring of that particular structure after application of the retrofitting. Now, as per IS 1893, it has been stated that there are certain attributes to be required for the better performance, so that the effect of the earthquake can be avoided and we can achieve the adequate lateral strength, stiffness, ductility, and integral action, which can be achieved by simple and regular configuration for a structure. Now, there are certain basic solutions which can be enlisted over here in little depth, but majorly contributed into the three types. The first is the application of new shear wall into the existing structure to carry out the drift control, to solve the irregularity issues, and to solve the new provisions. The another one solution is nothing but the steel application of the steel bracings. It is very much effective, specifically for retrofitting technique is concerned, to dissipate the earthquake energy. But here, an important thing is that the connection is a crucial criteria between the bracing and the concrete. Third one, retrofitting solution is jacketing. Jacketing may be carried out with the help of steel, maybe with the help of the reinforced concrete, and with the help of the fiber reinforced concrete. Here we can also apply the jacketing with the help of the FRP fiber reinforced polymer sheet. This will increase the drastic strength for that particular concrete or a joint. Generally, the retrofitting techniques can be bifurcated into two types. One is global retrofitting technique, another is the retrofitting technique local. Now, global retrofitting technique means which is applicable for the whole structure, and local retrofitting technique means which is applicable to the specific structural component. So, if we say that for the global retrofitting technique, the one approach is the adding of new shear wall, adding of roofing wall, adding of bracing, adding of wing wall or buttress, carry out the wall widening or wall thickening, or maybe reduction of the mass, or maybe the application of any damping or base isolation. This will we have to carry out for considering as a whole structure. For local retrofitting technique, it can be used as Jacketing of beams or column or beam column joint, or strengthening or jacketing which has been carried out as an individual footing. So this is nothing but the different retrofitting technique. Now let us go with the first one, it is the jacketing. What is jacketing? How it has to be applied on the structure? This we discuss over here. It is the most popular method for strengthening of the beam columns, and at the site, it is the most structural engineering are preferred the jacketing as a technique for retrofitting structure or retrofitting of a column or maybe a beam. The purpose of jacketing that it increase the concrete confinement, and this concrete confinement may increase the shear strength as well as the flexural strength of the complement of the structure. This will also increase the strength and ductility. Here, a most important thing is that the adequate connection is to be needed for new and old concrete. Here, the additional longitudinal bars, which is to be continuously through the slab and to be anchored to the foundation. Here, the replacement of the old bar which has to be pulled out. Here, the additional ties which has to be kept as per the seismic detail. Here, there are some of the images shows clearly about the jacketing is there. The first one we will go with the column jacketing. So before I proceed and explain the column jacketing, let us proceed with the one small short video so that we can understand very well the column jacketing. There will be one video is there for the overlays, but let me start with the column jacketing. Before I can proceed with the column jacketing, let me check the voice over there. Here there will be a systematic procedure which has been explained for the jacketing. Just show very carefully. Another video, please show the column jacketing. Now you just see over here in this video, the holes will be provided throughout the slab. So the reinforcement is constantly provided from the bottom part of the slab to the top part of the slab. So there will be continuous reinforcement which has been provided. And this reinforcement which has been provided finally with the help of epoxy grouting which has been done at the hole. The another thing is that you just visualize over here this reinforcement. Specifically this blue shape, actually this also has to be inserted inside the concrete, which is nothing but a key. The function of the key, this shape, blue shape which has been there, the function of that, I think my voice is clear? Hello, my voice is clear? Okay. So here it has been shown that the function of key is not only put up the reinforcement together, but it creates the bonding between the old concrete and the new concrete also. So it's just only not the function of that one. See the various places the key which has been inserted, and the reinforcement is not to be put anywhere, it has been provided throughout the slab. So intention of this show the video is the same as the more as previous one, but to show nothing but a key portion, the key which has been applied. Now let us proceed further with this presentation. Is it visible presentation? Okay. Now, the column jacketing is done to improve the load carrying capacity of the column, and the basic procedure is open the footing of the column by excavating soil grounded, remove the plasters from the surface of the column, make the surface of the column concrete rough by sand blasting, remove the coated bars by cutting them, add new bars from the footing to the slab as per the design requirement, and provide the shear key. As I stated, the word shear key which has been shown on the video part. Apply the bonding agent on the old concrete for proper bonding between the old and new concrete. Then apply concreting as per the design requirement. The shear key which has been shown in the image, you have also seen in the video, where it is to be provided, it is to be, first of all, we have to provide a drill holes to the specified diameter and depth to receive a shear key. Clean the drill hole by blowing the air, inject the epoxy bonding paste in the drill holes to fill it from the ends to half the holes, insert the L-shaped shear key and allow epoxy to cure. What are the functions of shear key? It bonds properly new concrete and old concrete. It holds the main reinforcement in position so that there will be a monolithic construction of the column can be done. Here, because of the shear key, the whole section will become effective. It also resists the shear failure. It improves the shear resistance of the column. It reduces the sliding effect between the new and the column. There are certain images for the jacketing of the column as well as the foundation together, which has been shown over here. Frequently, one term I am going to use: provide the reinforcement throughout the slab, not to cut the reinforcement near the column. Another images for the typical column jacketing. Now, bonding agent used. It is needed to properly bond between the new concrete with the old concrete, so as the bonding agent should be applied to surface of old concrete before casting of the new concrete. Generally, epoxy bonding paste is used as a bonding agent. This bonding agent is not only bond the old concrete with the new, but also creates the whole section effective. Admixture used. Here, a hyperplasticizer admixture is used with the new concrete to increase the strength and workability The function of admixture is to create the concrete to eliminate the difficulty of vibration, to increase the strength of the new concrete. Another one is the steel jacketing. The jacketing is the same phenomenon that has been done neither in case of the concrete jacketing or the steel jacketing. Here the material which has been changed and we are using the steel jacketing. So before I'm going to proceed further, let us just see one small video related to this steel jacketing. I think it is visible. Is it visible? Video? Now let us understand what is steel jacketing after looking to the video. So now there will be the doubt maybe in your mind which has been cleared. What is steel jacketing? Here the jacketing process which has been carried out by inscribing the column with the steel plates and filling the gap with the non-shrink ground. This provides a passive confinement to the poured concrete. Its resistance in action and hook direction, which can be excellent. The main advantage of the steel jacketing is it does not significant weight to the structure, but with the concrete, but also save the curing time. But the disadvantages of this method is require heavy equipment to handle and maintenance, which is very difficult. Since the steel jacket is vulnerable to corrosion and impact of the floating materials, it is not to be used for the columns in river, lake, and seas. There are the certain images which is clearly shows over here the use of the steel jacketing. Now next is the beam jacketing. We have seen the column jacketing. Similar way, the same fashion, the beam jacketing which has to be carried out. To increase the strength, beam jacketing has to be carried out. The basic procedure was the same as the column jacketing. The surface of the old concrete is cleaned by air jetting so that any of the debris is that it can be removed. Expanded, the wire mesh is fixed on the two sides and the bottom of the beam, or as per the design requirement, apply the additional reinforcement. To ensure the good bond between the old and the new concrete, an epoxy bond coat is to be applied to the old concrete surface. And finally, the concrete can be filled out as per the design. See the images or the figure. The original size of the beam section will be enhanced by the checking procedure. Next, some other noises there. Nero, condenser, please see. Some other voices there. Some interruptions is there.
It is clear, sir.
Okay. Use of bracings as a retrofitting technique. Some other voices also there. Condenser.
I think
fan voice is there. I think you just remove your one, sir. Probability. Okay. Now, use of bracings as retrofitting. The use of steel bracing system for strengthening or retrofitting seismically inadequate reinforced concrete frames is a viable solution for enhancing earthquake resistance. This bracing system reduces the bending moment and shear forces in the columns, so the lateral load is transferred to the foundation through axial action. Here, the total weight of the existing structure will not change significantly after the application of the bracing. The steel bracing, which is economical, easy to erect, occupies less space, which has been flexibility designed for meeting the required strength and stiffness. But one of the drawbacks is the connection between the steel bracing with the concrete. The bracing system improves not only the lateral stiffness and the strength capacity, but also the displacement capacity of the structure. See the images over here that the bracing technique can be used for the retrofitting of the structure. Beam column joint strengthening. We have seen the beam jacketing, we have seen the column jacketing. Now the beam column joint is the beginning part for the earthquake load is concerned, for the seismic region is concerned. So here the beam column joint jacketing can also be carried out. So since the construction material have a limited strength, joint have a limited force carrying capacity, so when the force larger than this applied during earthquake, joints are severely damaged. So repairing of damaged joint, which is difficult, so the damage must be avoided. So beam column joint must be designed to resist the earthquake effect. Now for beam column joint, maybe the concrete jacketing can be used, maybe steel jacketing can be used, and another one is the FRP wrapping jacketing, fiber reinforced polymer wrapping jacketing can be carried out. See some of the images which can be shown over here, which is used for the beam column joint. The first one is the concrete jacketing. Another one which is used is the steel jacketing for a beam column joint, and use of the FRP jacketing may be used for a column, for a beam, or maybe with the beam column joint is concerned. So now in retrofitting technique, let us go what is FRP and how the FRP can be used for the jacketing purpose. Before I proceed further, for the beam column joint or maybe a composite material, it is will look like a very small video so that we can understand very well about the FRP jacketing. So step number 1, it has been seen that the step number 1 is the surface preparation. Surface preparation is the main parameter for application of the FRP. So first of all, remove the debris is important one. Make out the surface clean. Make the round the corners so that the sharpened edge will not be effective for the application of FRP, so that the air will be entered inside. So we have to see that we make some round corners. Then application of the priming. Fill the bung holes that will be there. So now you can see over here, after preparing the surface, they have filled the holes, then they have applied the first is the primer. After application of the primer means to carry out a certain environment for the FRP to apply on a beam, maybe apply at a joint, maybe apply on a column. So it creates a certain favorable environment for the application of FRP. Then apply the sheet of FRP over here on that particular component, and then apply the saturant so that it will be attached to the concrete. Now, another video will be shown later on, but because we start what is exactly the FRP, it is nothing but a composite material. It is a material which is created by the combination of two or more materials on a microscopic scale to form a new and useful material with enhanced properties that are superior to those of the individual constituent alone. So which has been FRP actually made up of the two materials. One is the fibers having a weightage of 50% to 65%. The main function is to carry out the load in the design directions. These fibers are being the main load carrying constituent which gives FRP its strength. While second one is the polymer resin matrix having a less load carrying capacity resin, but which is act as a medium to transfer the stresses between the adjoining fibers due to the adhesion. It also provides the protection for the material from UV ultraviolet rays and damage. So FRP is basically made up of the two materials is shown in this visualized. Fibers provide the strength and stiffness. The examples are carbon fibers, maybe glass fibers, maybe the aramid fibers. Whereas the matrix which protects and transfers the load between the fibers, maybe epoxy matrix, maybe polyester matrix, or maybe polyester matrix. And combination of this two composite is known as the FRP material, which creates the material with attributes superior to either component alone. So if we are using the fibers alone, if we are using the matrix alone, having no use, but if we combine together, it will become a new composite material, FRP. There is certain application procedure. The first one is remove all unsound concrete induced particles, arrest the corrosion, make it of original shape, grind the corner, make the surface smooth and undulation free, and then apply the adhesive. First is the primer, apply the FRP, and then apply saturant, that is base plus hardening, and that is the final in etching. Then press the wrap strip by the hand, use roller to remove the air, put another coat of adhesive, and finally apply the coatings. This is nothing but the application procedure of the FRP as a retrofitting technique. So step number 1, which has been shown over here in the image, that is nothing but the surface preparation. The surface preparation has been done by removal of the maintenance, removal of the paints, debris, curing compounds, etc. by sandblasting or by any other means of the technique. Another, the way of approach of surface preparations, which has been shown on the images. Then the grinding, the round the corners which has been carried out of a specified radius. Why the rounding corner which has been carried out? So that the stress concentration which has not been done when there will be FRP which is to be applied. Also, there should be not any kind of air should be entrained inside to the FRP. Another approach of the surface preparation means the fill bug holes, pinholes, honeycombs, warts. Means the repairing of the imperfection is to be required, and we have to create an even surface. Then apply the priming the substrate. Application of the first layer of chemical onto the surface. Then there are two types of the application of FRP. One is the manual weight, another is automated weight, and third one is manual dry. So what is automatic weight? The FRP and the saturant has been combined in the factory itself, and that FRP we have to just put on the concrete surface. Well, manual weight means manual application of the hardener, which has been done onto the FRP and then which has been applied on the surface. Similarly for the manual dry. Application of FRP on the different components. The first one, which has been shown the image of the glass, as the color itself shows, it is glass fibers are then involved in the GFRP, and the black color shows it is CFRP. It's also the same thing application. Removal of the voids which can be carried out. This is the final finished product, and if you go for the coatings, for the aesthetic look, for the UV protection, for the heat protection, you can apply the coatings also. So this is nothing but the whole procedure for the application of FRP for the retrofitting technique is concerned. Before I proceed further, let us show one also video related to surface renewal. Surface preparation which has already been done, they are going for application of priming. Then application of the FRP sheet to see over here. And then once again on the FRP, there has been applied the final hardener over here. Next, another video for the repair of strong limit column. corner of the column which has been cutted down, then apply the additional reinforcement at that particular places, and then application of the FRP so that the column which will become as a circular one. We just show the image, and then the filling inside by using the regular material which is the concrete. So the way of application of the FRP is also shown in this way also. The another one, the retrofitting technique, is nothing but the application of RC structured wall, which is also known as the shear wall. When RC concrete wall or a shear wall are designed and constructed properly, then they will have the strength and stiffness to resist the horizontal forces, and it prevents the rotation of the joints. This is the important specifically in high-rise buildings subject to lateral load, wind, and seismic forces. So the shear wall is nothing but the reinforced concrete wall, which is widely used for movement to the high-rise building to provide the lateral strength, stiffness, and energy dissipation capacity required to resist the lateral loads arising from the wind or earthquake. It is also important to retrofit itself an existing RC wall, which includes a repair. It also includes a rehabilitation. It also includes a strengthening term also. So if we go for the rehabilitation and the strengthening terms, which is used when the performance of the existing wall does not satisfy the existing requirement of the design course, needs to be enhanced, while the term strengthening is used when the wall was not subjected to any damage and we have to go apply the high strength, while the term rehabilitation is used when the wall has already been damaged and its resistance needs to be restored and improved as well. If the damaged wall's performance was satisfying before the damage occurred and it is needed to restore its capacity without any additional resistance, then the term repair will be as a representative as shown in the images in use of a shear wall as a retrofitting technique. One of the way is to use the infill wall as a retrofitting technique, which has been used in the 2001 during the Bhuj earthquake for an open ground story building. As open ground story building is more susceptible for the earthquake, so here the open ground story can be avoided by providing the infill wall, so that the whole building will act as together and it will not attract more earthquake forces at that particular place. Now let us go with the next terminology, that is rehabilitation. Restoring the structure from a damaged conditions to the functional conditions can be termed as rehabilitation, which includes what the first is the assessment, the damage, determination of the feasibility of repair. Then we have to decide the best method which is to be required for a repair, preparation for the scheme for the reconstruction, and finally prepare a scheme for propping and bracings, include the schemes of the proper loads. So by strengthening means of reinforcement, strengthening by means of external pre-stressing, strengthening by externally bonded steel plates. Now, some of the typical examples where the repairs and the rehabilitations required, you just see in the one of the images that there will be roots of the trees will be affected over here at a joint of beam and slab, which will weaken the places and the cracks will be there. So here the specific strategy we have to apply for the repairs. Another example here clearly shows a long horizontal crack shown over here clearly because of the deflection of the slab and lifting of the edge of the slab combined with the horizontal movement in the slab due to shrinkage. This requires a rehabilitation strategy so that we can maintain the same strength as the previous one. This is nothing but the opening of the doors or windows, right? That will be a crack can be visualized. So these cracks are due to pull exerted on the wall by slab because of the drying shrinkage and thermal contraction. This pull results in the bending of the wall, which causes cracking at a weaker section, that is at the lintel or sill level of the window opening. Such cracks generally occurs when the windows and the room spans are very large. These cracks can be avoided by providing slip joints at the slab supports on the wall. This is one of the typical kind of the things can be visualized in the older structure because of the higher silt contained in the plastering work. Yes, inclined cracks, which is can be visualized because of the longer opening and the less bearing due to the lintel load carrying capacity, which expose the diagonal cracks, which is require a specific rehabilitation technique. Vertical cracks as well as the horizontal cracks combines over here under the window when the wall have a larger window opening and little wall space on both the side of the opening. So here the difference in stress due to more stress in the wall portion adjoining to the window and the less stress portion under the sill of the window resulted in crack. Definitely the reinforcement has been visualized over here. So there are certain techniques can be used to provide the repairs and rehabilitation strategy. Finally, I'm winding over here. Thank you very much. Questions are to be welcome if it is any. If there are no questions, no questions any. So let me run it out.
If you have any, you can write in the chat. Participants.
One question which has been arised by Dr. Praveen Singhai sir, how much of the retrofitting will cost? It depends upon the type of the strategy which will be adopted for a particular situation. It depends on the type of the defects or type of the things which has been occurred, the type of which retrofitting technique we are going to adopt. It depends on the things. Any other questions? Grouting material is used for the gap filling or increases strength and durable also. Grouting can be used, first one, maybe as a gap filling, yes, definitely. In certain cases, when there will be a good bond, see, grouting doesn't increase the strength, but the good bond will increase the strength. So definitely it will increase the strength if the good bond is there. There are so many historical buildings has been adopted the various retrofitting technique. There are so many historical buildings. Yes, I haven't placed any slides over here, but there are so many historical buildings retrofitted. Jacketing. How does the jacketing work? Jacketing enhances the, first of all, if we are using, let example, reinforced concrete jacketing. When you are applying an RC jacketing, you are applying additional steel. Also, you are applying additional concreting. So effectively, you are increasing your cross sections. Means when you are designing for any kind of the cross section, maybe a beam, maybe a column, your reinforcement and the concrete will contribute to the strength. Finally, through the jacketing, you are increasing the cross section. You are providing more reinforcement. You are providing the more what can I say, concrete, definitely the strength will increases. For that, our simplest IF 456 formula can be implemented to find out the increase in the strength. Can jacketing of joint be done for existing building without causing serious damage? Definitely can be done. There are lots of researches which has been done, and also the practices has to be carried out without affecting serious effect to the existing structure, and jacketing can be done. It has been done, and on the FRP, if doing proper FRP, you can do the things very easily. Yes, sir, Dr. Praveen, sir, there are good pumps definitely available in the market for the grouting. In jacketing, how to fill top junction of column and beam. First of all, as shown in the videos, also you saw the photos, the column and beam joint, that is the junction, is definitely an important term. If you are going for the reinforced concrete, particularly as a retrofitting technique, as a jacketing technique, then as has been stated, if the column reinforcement go from throughout the slab and beam reinforcement are interconnected between the column and beam, so that they will be behaved as act as a one, and then the final component which is to be carried out, instead of carrying out the jacketing individual as a part. Next question. As far as cost of the structure is concerned, is there any criteria up to which the strengthening of the structure is possible? Like if the cost of the structure is more than this much percentage of the cost of structure is to be demolished in the reconstruction is done, then as far the structural engineering concerned, there will be a different provision given by certain local authority. I can say the example. The damage type. If I can say the damage type 1, 2, 3, 4, and 5, which has been enlisted over here in this local region. If when during the visual inspection and during carried out certain NDT test, if they feel that it is under the criteria number 5, then instead of going to carry out any kind of the retrofitting technique, you have to go for the demolish the structure and reconstruction can be carried out. But if it has been carried out the criteria number 4, damage type number 4, then the specific type of the retrofitting technique which has to be adopted. So this kind of strategy which has been given, as far as the Gujarat region is given, this kind of strategy which has been given by Road and Building Department itself. Is there any questions? I think there is no questions from the chat box which can be visualized over here. Once again, I am waiting for the response. If any questions is there.
Thank you,
no
sir.
Questions, please.
Yes, I think that was all of those questions. If anyone has any more questions, they can write in the chat box.
No questions.
Thank you, sir, for this amazing seminar. Now we'll take a break and then we'll start the third session at 3:30. Thank you.
Thank you very much. Now we are going to take the session start at the 3:30. Just we will take a तो ये कोड क्रिएट करेंगे कोड कैसे कर सकते कोड क्रिएट
हाँ क्या चलो इनको सर अच्छा होता कॉन्सेप्ट तो
चार चाला चार चाला अच्छा है
हाँ सर बड़ा
दस वाला लगा
चार चिक्की कोई भी
चिक्की ये भी तो पहले से 5 वाली है चिक्की खाए चिक्की चिक्की
आपका कोई भी चांस
जान एक का जाएंगे भाई ये कौन नहीं भाई मैंने वेतन नहीं दिया
मैंने चार ना चार कोई बीजी गाड़ी
मारी गाड़ी से पेट्रोल पड़े છે उसको પેલા ની બેન
ना सर बाइक नहीं देती मुझे गाड़ी चाहिए
नीचे में क्या हां वो नीचे में अरे आई थिंक सर नाउ इज बिजी बता अरे आ लैपटॉप में जा आके चलो आपने कोई बिजी हो गया मैं तेरा व्हाट्सएप कर दूंगा दो सेशन का नाम की दिया अब लगता है टॉपिक में खाली सेशन थी डे 1 डे 2 ये टॉपिक खाली डे टाइम અને और बस आगे दे देगा बाकी दूसरा नहीं बस अगर बंदा से मैं बात कर रहा हूं अच्छा गाना बोल रहे अरे आप तो मुझे तो ना मुझे तो आई बार मुझे मैंने काल सवाल में कोई बाकी उतना एक केस में कर आई कंप्लीट भी आप जोड़े आपको मिलेगा अच्छा कितने के नीचे जाते हैं तो मुझे जो कॉल लेते हैं और वीडियो आप जब आप कॉल बना ये ओपन कर चाहिए नीचे साथ चलो चला के हमें मोबाइल नाम आपके पास ला के बता दो मैं थोड़ा स्विच करूं साइड चलते ये एक्स्ट्रा है आई विल यूज द साइड शांति भी बहुत बड़े से ये विचार के कारोबार नहीं है बस इसीलिए बड़े का कारोबार नहीं है शांति भी तो खाली नहीं है तो आगे हम खतरा की नहीं है ठीक है हाँ बोलिए मुझसे अलग चिक्की दसना पूरा सराड़ी छोड़ो मिठो चिक्की नहीं अरे चिक्की खा रही कोई काम कर लिया ऊपर सप्तम का है तुम्हारा सप्तम का है तो भी कोई दिक्कत नहीं ये कल्याण वाला से कल्याण नीचे नीचे का इनका नहीं है मैंने क्या को सराड़ी जोड़ के देखा अरे बाहर में नहीं आ रहे हैं सराड़ी जोड़ के पहले चाल ठीक है अरे ये लाओ बोलना ठीक है this is ये क्या समझ